Okay, our topic is parametric equations. And parametric equations are very similar to equations that you're already used to, which is you're used to a rectangular equation. A parametric equation basically breaks down this line into a line of motion. So it always has direction. You can see the little arrow. That is a part of graphing a parametric graph. And it also has speed. So parametric equations introduce a third variable, t. We call it the parameter. Typically, that's standing for time. We're splitting a graph, the motion of it, into an x and y component so that at any time t, we can plug in and get its x position and its y position. In a rectangular equation, we have two coordinates, x coordinate and a y coordinate. In a parametric equation, we explain them in functions. So it's an f of t and a g of t. It's going to be some sort of, not equation, but expression like these written as coordinate points. So we're going to start by sketching the curve given by this parametric equation. We're always given the parameter t, which basically tells us what do I start with and what do I end with. So what I'm going to do is take my parameters t and fill them in the t row. So that's going to be, I'm going to start at -2, -1, 0, 1, 2, and up to but not including 3. Then I'm going to take t and I'm going to plug them into the x equals t squared minus 4. So t squared in this would be 4, minus 4 would be 0. T squared, taking this, t squared minus 4, finding the answer and putting it in here. 1 squared minus 4 would be -3. 0 squared minus 4 is -4. 1 squared minus 4, -3. Oops, and that's not a 3. 2 squared minus 4 would be 0, and 3 squared minus 4 would be 5. Okay, now I'm going to plug it in and get my y coordinates. So t divided by 2, and plug them into the y row. -2 divided by 2 would be -1. -1 divided by 2, -1/2. 0 divided by 2 would be 0. 1 divided by 2, 1/2. 2 divided by 2, 1. And 3 divided by 2, 3/2. And now I'm going to take them and plot them on this graph. Okay, I'm going to start with the point 0, -1. There's my first coordinate point. 0, -1 is right there. I have to remember that's my starting point. This is going to make a path. It's a path of motion. Then I go to -3, -1/2. So if my graph was extended a little bit, let's put some tick marks in there. Okay, -3, 1, 2, 3, -1/2 would be roundabouts here. -4, 1, 2, 3, 4, 0. -3, 1/2, 0, 1. And 1.5, and I'm sorry, 5. 1, 2, 3, 4, 5, 1.5. Okay, parametric equation. All I did was plot points, but then I connect them. It's a connect the dots game. I've got to have direction. My path was going this way as t was increasing. And there we go. You've graphed it. You can look at it and say, okay, to get from start to finish, to get from start to finish took me -2, -1. So if I started at -2 to 3, that'd be 5 units to get from start to finish. Okay, we're going to do the same thing here. We're going to create a table. My t, I'm going to start at -1. I only go to 1.5, so I'm going to count by halves. 0, 1/2, 1, and then this one would be 3/2. If I plug in -1 to my x's, 1/2 would be 1/2. 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 1 Negative 1 squared is 1 times 4 is 4 minus 4 is 0. Negative a half squared is 1/4 times 4 would be 1 minus 4 would be negative 3. This would be negative 4. 1/2 squared would be 4 times 1/4 minus 4. So I have, what is that, 1 minus 4, so negative 3. 4 minus 4, 0. 3/2 squared is going to be 4 times 9/4 minus 4, so that's 9 minus 4 is 5. Y equals t, so that's an easy one. Just duplicate that t row. Now we're going to plot them. I've got 0, negative 1, negative a half, negative 3, negative a half. So I'm going to extend my graph here. Let's put some tick marks again. Negative 2, negative 3, negative 4. Kind of overlapping a little bit here. Negative 3, 1, 2, 3, negative a half. Negative 4, 0. Negative 3, 1/2. 0, 1. And 3, 4, 5 to 1.5 here. Always make sure you connect it with a path. Here's my path. Give it direction. Looks very similar to the one we just did. What's the difference between the one we just did and this one? And the one we just did and the one before? Look at our starting point and our ending point. My t was negative 1 to start, and to end, t is 3/2. Okay, so that means I had 1, 2.5. 2.5 units in t from start to finish. Same path, same graph, different speeds. Okay, your calculator can also help you graph parametric equations. When we go to mode, most of the time we're looking at radians and degrees, so go to the same menu. Under mode, you'll have a line that'll have you choose between rectangular, parametric, and then there's polar and something else. Choose the parametric if you're graphing a parametric. Now, your calculator will not give you a path, so you have to watch it graph if you want to see that. But when you change it to parametric, this is what it changes your graphing window to. So you can put in your t squared, and you can put in your t cubed, and then notice you're entering variables as t. So when you're pressing that X button, it's entering t, and the window setting will now allow you to enter your parameter. So that's where you set your parameter. For this one, it looks like it would have been negative 4 greater than or less than equal to t, less than equal to 4, matching to the minimum and the maximum. Then you can press trace, you can trace through points, you can look at your table. Again, you're going to have to watch it graph to see the path. Okay, when we have a parametric equation and we want to change it back to a rectangular equation, it's all substitution. Solve for t in one equation, substitute it into the second one. Typically, we want to end with a y equals equation. So we take our x component and solve for t, substitute that into the y component, and then we'll be set. So I start with my x component. X equals 1 over a radical t. I get the t by itself. So multiply my radical t over. I get divide by x. Radical t equals 1 divided by x. Get rid of a square root. I want to square the other side. So that'd be 1 over x squared. Then I'm going to take this t value and substitute it into there. Y equals 2 times 1 over x squared squared. So y equals 2 times 1 over x to the 4th. So y equals 2 divided by x to the 4th. Okay, when we're finding a parametric equation, you're always going to be given part of it. So in this case, we were given y equals 4x minus 3. The problem, which I don't have typed out, is when the other part is t equals x. It's got to give you some kind of parameter so you can find the parametric. Well, all we got to do is solve for x. Okay, so x equals t. And second, we're going to substitute. Where we have that x in here, we're going to substitute y equals 4 times t minus 3. So now we have two equations, x equals t and y equals 4t minus 3. Parametric equations, you've got to have an x component and a y component. Okay, different example. What if they gave you the parameter t equals 2 minus x? Well, if I add my x over, subtract my t, x equals 2 minus t. Substitute in y equals 4 times 2 minus t, minus 3. So y equals 8 minus 4t minus 3. So y equals negative 4t plus 5. X component, y component.